Welcome back to episode 5, Project Finance Modeling. Today we're going to work on our construction financing, or what I typically call financing plan or fin plan. I've sped up the video a little bit and set up the structure. So last video, I showed you how I would add new tabs to a model just by duplicating previous tabs. So I've done that here already. Our case study calls for a financing structure of equity, debt, and government grant. So I like to always show sources and uses at the top of your financing plan. Really important to just know what's happening, what kind of capital are we spending, how much equity, when is equity. Next thing that's important is actually seeing what we're being funded. So lenders will care about what level of contingency is in place, what the sequencing of debt is, what we're relying on, how much equity and when. Now, how you build that is all the mechanics down below. So what I've started with is a static spend curve here. So our first step is going to be actually showing what kind of capital we're spending. And all we're going to do here is just times by our input. And I've set up our input sheet and we have our costs. I've linked those into the fin plan and I've also colored this green. Our construction schedule is going to be monthly. So I've modified this. Start of January 21, like all the other time series, but then end at December 2026. So I have 12 months of buffer from the start of operations. All we're going to do is times our input, times our static spend curve, our CapEx outlay under our base case. Have our total CapEx row. So we're going to total this row, and this is going to go right down into our financing requirements. Now, our financing requirements are going to be exactly the same as our total use. Everything we need to go in and fund to go in and complete the project. And this is really essential. It's what is the capital required to go in and ensure we have a fully functioning project. And there's all kinds of interlinkings with the IE, what level of contingency should be in place, the timing of your equity, government grant, to what extent are those in hand at financial close. The less that's in hand, the more contingent equity is going to need to be in place. You need a fully funded financing plan. So that means you have all the sufficient equity commitments in place to go in and ensure that the project will be funded. And oftentimes that's a percentage of the total financing plan. So it'll be 110% of the financing plan. And within that financing plan, there's a CapEx schedule that also includes contingency. So there should be several layers of buffer go and ensure the project gets funded. And those buffers are to go and account for cost overruns and construction delays, which often go hand in hand. So now we have financing cost during construction as well as transaction fee. Total equity commitment. So open, contribution, close. So we're going to go back to the case study and look at our equity mix is going to be 40%. So we're going to put this as a new row in our construction. We're just going to call this capital commitments. So now that we have those inputted, financial structure calls for a mix of equity, debt, and government grant, and the capital needs to be equity first, then debt, and finally by grant. So this is pretty typical. Governments don't want to commit to a project until it's fully funded and on its way. They basically just want to be an economic surplus to the project and not really be on risk for execution, procurement, and all the risks that encapsulate construction. Debt is very often pro rata, and in riskier projects, it will be equity first. Equity is either first fully deployed or pro rata. And the most aggressive sponsors will ask for debt first, but these are, your KKRs, your Brookfields, your Stone Peaks, like the prominent infrastructure investors that really can lean on their lenders for more favorable terms. Generally, project finance 101, you want either pro rata or equity first. So we're going to take our equity commitment and we're going to link this in. So this is total financing requirement. And all we're going to do is just times this times the total. And that's our equity commitment. So we have 16 million going into the project. So then all we're going to do minus our opening schedule is our remaining equity commitment. And our open is simply going to reference the prior period. Our contribution is going to be the minimum of our available equity commitment and the total financing requirements in each period. And then we're just going to put a max formula just for what I would call safety. We're going to introduce circularity and then remove that circularity eventually with a macro. But we just want to ensure we're never negative funding equity or any of these sources, because negative funding basically means a repayment. And in a future video, we can certainly talk about dividend recaps, but this is going to be very linear and simple. So you'll see December 2022, we funded all the equity. And then we're going to add in a simple line, financing requirements after equity. Simple mechanic. We know what's left to fund in the period for debt in the government grant. So this formula is just going to be our financing requirements less our actual contribution. And it will be 0 until the equity is exhausted. So now we're basically just going to copy a lot of this logic down, and we're going to get to debt. And for debt, we're going to simplify this a little in our interest calculation, and we're just going to simply take our all-in interest rate and link it over. Typically, you would have your own buildup, but for simplicity, we're going to just take it from our debt tab. You know, arguably that's proper mechanics because you have one source, and then you're simply just going to take your opening times your all-in interest rate times your frac, your period, and then we'll have a flowing interest calc. But what we want to understand is what's our available commitment. So we're going to make a little module called debt size. We're going to lay out what our constraint. So first is debt project costs. Worth mentioning that project cost includes CapEx, interest during construction, and your transaction costs. So it's your entire total financing requirements. So these all kind of go around. For debt, we're only allowed 36%. So this is simply going to percentage of the total financing requirements. So 14.4 million. We're going to also have cash flow sizing, and it's the lower of the two. So cash flow sizing constraint is a 130, and this is just going to be a link to our actual sizing. Our debt size is obviously, so I've just converted this to millions really quickly as our cash flows are in millions. Our constraint right now is what's called gearing. So what gearing is basically just debt to project costs. And as we link in our actual debt size, right now it's based on legacy logic and including a bunch of cash flows that wouldn't typically be included. So all the merchant cash flows and a much longer debt structure. So we're going to leave this for now and we will clean it up in future videos. The mechanics are all the same. So then our debt size is just simply going to be the minimum of the two above. And that's going to be our available equity commitment is what goes in and governs all of your sizing mechanics. So now our 14.4, we have a stale link here. So we're going to pull this down, be our debt amount, and you'll see we fund exactly. So we're going to pull down our FinRec after equity and debt. And all this is going to be this number, already net of the equity, minus our contribution. You'll see we have a funding requirement in September 2024. I have a couple more things we want to add. Dictate when financial closes. And we're actually going to bring up our construction section, as I like to sequence things in order of their timing. So the way I think through it is you need a financing to start your construction. You need construction before operations. Timing, financial close, pull that into our fin plan. Okay, so simple and formula. Basically, does this financial close occur within this period? And the reason we want to do this is we need transaction percent upfront fee for lenders. So we're just going to call this debt transaction fee or transaction fee times your debt commitment times your upfront fee or your financial close fee. Now we have what has basically created circularity as our total financing requirements includes transaction fees and our debt size is a percentage of our total financing requirements. So those are circular. And we're going to create further circularity with our IDC. For the current version of the model, you're going to Excel option, so Alt F file T options at the very bottom, and then go down one to formulas and just enable iterative calculations. And that's going to iterate this until it finds this, it starts solving for the same number. And we're going to remove all circularity with macros in the future. The next thing we want to do is create our availability period. Our availability period is just going to be our financial close to our operating period. So we're going to take the same input and we're going to link it as a driver. And we're simply just going to link to our financial close. And we're going to take this logic and instead of Jan 1, 2021 for our second bracket, we're actually going to use Jan 1, 2026. So simple and formula. So the availability period is basically we've closed the transaction and we haven't term converted. Our last formula or flag is our term conversion. And we're just going to make our term conversion 1 day prior to our operating period to go in and indicate when we're term converting. So we go down to our debt schedule. We're going to add in a row. We're going to basically go in and say, this is no longer construction ability. It's now a term loan. And we're going to begin to start to amortize. So we're just going to times our interest, times our availability period. And that's going to clean up a bunch of this noise here. The commitment fees are usually a percentage of your margin. So what we're going to link in to our fin plan, our margin, this is going to be 35% of our margin. So what commitment fees are is a fee for the capital that has not been drawn on. So here's available equity commitment, and that's basically our undrawn capital. So we're going to take our available debt commitment times by our commitment fees, and this is form our financing costs. So to reiterate, couple key things when modeling debt during construction, you need your availability period to go in and stop your interest calculation once you've term converted. You need your financial close flag and your term conversion flag to go dictate when upfront fees are paid, and your term conversion to go and take out the debt and start repaying it, terming the debt out. But essentially we have our debt fully modeled here. So we're just going to copy down the logic from equity again, government grant requirement, and we're going to take our total FinRec here, pull this across, and now we have our government grant funding. Let's go link up our sources and uses. So our CapEx is just simply CapEx, finance costs and transaction fees. Pull that over. Our sources are just going to be the actual contributions for each of these. Our equity, our debt, and our government grant. So we have our sums, sources and uses equal. Now the moment of truth and how you test if your model is correct, we should have 40% equity, 36% debt, and 24% government grant. Go to our fin plan. We're simply just going to divide this by our total uses. We are almost exactly correct, and I'm gonna is 24.00 and also 36%, exactly in line with the case study. Shows you that we're modeling and drawing on our capital correctly. That's it for today's video. Please like and subscribe if you enjoy the content, and feel free to email me, which is included on my channel. If you want the model, I'm happy to provide it, and also put some comments in what was confusing, what you want to see next, and I'd be happy to explore those subjects. All the best.